Okay, now that I have the hierarchy nodes, or the top level hierarchy nodes set up in Ampla, what I'm going to look at doing next is setting up some simulated tags that I'll then go on and use to automatically capture and populate some records with. So in order to create that simulated data source, I'm going to open the system configuration folder. I'm going to add a node underneath there, and I'm going to create a folder called data sources. Okay, it's typically best practice to keep your data sources up in the system configuration folder, and there's a number of reasons for that, but one of them is that putting it up in the hierarchy here, the security, when the user opens a client, it doesn't actually need to validate all of the items in the data sources as it would if you were to put them down in the hierarchy. So keep your data sources up in the system configuration folder as a general tip. Okay, so now I'll go and create another folder, and I'll call it sim data. Okay, now within here what I'll do is I will add a utility item, which is a number generator. Okay, so this number generator, once I save that, I'll start that by doing a tree start, which starts all nodes regardless of their setup. Okay, so that number generator, what you can see here happening is that it has a number of different outputs. So you can see that it's recording the day count for the month. It has, the hour of the day, a bunch of different outputs, the minute, month, and then it's got these random numbers that are essentially doubles, and you can go right down. So what's happening here is that it's constantly updating these numbers based upon this update frequency. Okay, so you can set the frequency that this random number generator outputs. So what I would typically use if I was simulating is I would leave it in default so it updates every 5 seconds or so, and then I would typically tap into these random numbers in here and then form some sort of calculated variable that uses these to output something that I can use to drive the automatic detection of downtime. Okay, so now what I'll do is I'll create a calculated variable that is using one or a number of those values to calculate. So what I'll do is I'm going to call this tag stopped. So we'll call it plant underscore stopped. So this will be my simulated plant running status. And I'm also going to give the actual number generator a sort display order group of 4 so it stays at the top of my list to keep it tidy. And I'll save that. So now my plant stopped calculated variable. Now I can go in and I can create an expression for it. So what I'm doing is I need to find that the random number generator. And what you'll see now under the random number generator, these are, I guess, the properties of that random number generator that we looked at. And this is where I can now grab these items and put them into an expression. So now I've gone and grabbed random, which is the first random value there, and I'm going to say if that random value is equal or less than say 50, then my calculated variable will calculate as being true. So I'll save that and start that, and you can see now it's outputting true at the moment. So what I also need to be mindful of here is the dependencies that drive this thing forward. So if I just check the actual stream content, so since creating that it's in a state of being true, but what I need it to do is to constantly reevaluate that expression so that it can go, obviously, change from true to false depending on what the random number generator is producing. Okay, so what we normally need to do is to create a dependency that pushes this calculation ahead in time, and I can talk about that in another video because it's a little bit tricky. So what we would normally do there is we would go in and create another folder. We'd call that timers, and then in the timers I would go and create a periodic time event, and I'll call that 1min, and that time event we'll have a duration, say, of 10 seconds. And it can start on a round number, like on the hour, and it will have a repeat interval of 1 minute. Okay, now I've saved that, so now I'll do a tree start and get that going. So what you'll find is that timer, now that it's been turned on, so it should be started here, the tag stream for that timer will populate with many different, true-false status, where it's essentially, it's calculating itself for the duration of the cache that's behind the Ampla project that we've set up. So by default it should be a couple of hours, and that's what you can sort of see here. So from 6:30 to say 8:30, which is my date time now. So it'll automatically populate that. So now that timer will fire every minute. So now I can use that timer to drive this calculation here forward, so that it doesn't just get stuck in time. So you can see here that at the moment, what I need to do is I need to add a time dependency into this expression. So I'm going to add in, see how it's got no dependencies in here? So that means it won't actually recalculate ongoing. It will sit there just at that number forever and a day. So we need to add that dependency. So now what I can do is I can grab my timers, my 1 minute timer, and add that. So now that's a dependency to say every time this timer goes off every minute, reevaluate this expression, because it is now a dependency on that expression. So if I save that, start that up, now what we should find is that this actual calculated variable now will reevaluate each minute, because it's being I guess driven along by that 1 minute timer. Okay, so we might have to wait a little while to see that occur, because obviously it's still dependent on that expression coming true. Okay, so what we'll do while the plant stopped calculated variable populates with some values, I'm going to go and create another simulated tag, and I'm going to call it plant feed rate. And then I'll create myself a simulated feed rate. And what I want to do here is I know that one of the random values that I'm going to hook up to produces a value between 0 and 100. So what I'm going to do here is I'm going to say, if I have 950 and I'll add that to the output of that variable, what I should have is, random. Yep. Okay, so now what I should have at any given time is a number between 950 and say 1050 being produced by this this calculation in here. So I'll just tick that now. So what that filter means there, it's not actually applicable for what I'm doing, but that actually stops the expression from calculating if the data quality coming into the expression is not good. So again, it's more applicable when I have a historical data source or something where quality is coming in off the data source. So I'd normally just tick that by default out of habit. Okay, so now if we look at the dependencies tab, you can see we still again don't have a dependency. So what I need to do again is I need to go and grab that 1 minute timer and add that as a dependency to drive that expression forward. So now if I save that and start that item, and you'll notice I need to, as I create items, we need to start them, or else they were in a sort of a not running or not initialized state. And you can see straight away it's taken that 950 value and added it to the output of that random number generator, and it's created a value for me of 1015.392 or so. So what I'm going to use that for shortly is my simulated feed rate going into my fictitious plant, and then I can use that to actually drive delay capture and an understanding of the rate that's being pushed through the plant. And I'll look at that in a later video as well. So now what we'll do is we'll just go back to our original plant stop tag, and we'll have a look and see if it's created any values based on that expression. So what we do is we look at the sample stream that it's created, and we can click on that stream and it can show us the values. So now you can see that when we started, it was saying it was in a true state, so the plant stopped expression was true, and then it's had periods of running time since then. So as it's gone through, it's evaluated at different times. It's actually said false, so it was running here, then it was stopped again, and now it was running again. Okay, so this here is able now to be used as a way to simulate a running or stopped value for this plant. Okay, so that's all I'll talk about in this video. In the next video, I'll talk about using those tags in a downtime reporting point in order to capture some data. Thanks for watching.